Today we're going to look at series circuit analysis. The first thing you should be able to do is look back at the lab that we did on series circuits and make a few observations. If you notice, the resistance that we have here, this is a nominal 10 ohm resistor, and when we calculated the actual resistance from our voltage and current readings, we come out something close. This should always be the case when you're using resistors. They're not made to a perfect tolerance, so they're always going to be off a little bit. In fact, this 10 is a 20% tolerance, so this could be anywhere from 8 to 12 ohms. So 10 is very good. Same way with the 5. The 5 could be off, could be 4 to 6, and it's 5.1. So the first observation that you should have made is that when you look at the current in the series circuit, it's the same everywhere. That's because there's only one path for the electricity to flow through. Secondly, if you look at all of the voltage measurements, the voltage measurements add up to the total voltage in the circuit. And lastly, the resistances add up to the total resistance of the circuit. So this column R12 is what the actual power supply or battery sees, you could say. So let's look at some of the questions. The current in a series circuit is the same. As you add resistors to a series circuit, the current flowing through the circuit will decrease. The total resistance in a series circuit can be calculated by adding the individual resistors. As you add resistors to a series circuit, the total resistance will increase. And the total voltage drop across all the resistors can be calculated by adding the voltage drop across each individual resistor. Within a series circuit, the largest resistor has the largest voltage reading across it. The reason for that is it takes more energy to push the current through the larger resistor. And so therefore, more voltage, you have a larger voltage drop, which indicates that more energy is used at that resistor. Now, let's apply this to our series circuit analysis. So if we pull out the series packet, let's get to this page. There's certain rules that we have in series circuits. The total resistance in a series circuit equals the sum of the individual resistors. We just saw that in the lab. In a series circuit, the current stays the same. In a series circuit, the voltages add up. Now, if we look at a typical circuit, here's a typical series circuit. The current's going to come from the power supply or battery, travel through the circuit, and whatever voltage we have here has to get used by the time it comes back to the battery. So let's start by labeling our resistors. So we have R1, R2, R3. R1 is 10, R2 is 5, R3 is 20. So that gives us a total resistance of 35. Just add them up. Now, the only other thing I know about this circuit is that the total voltage is 10. So this total is what the power supply or battery sees. It doesn't know what it's actually hooked up to. It just knows that there's 35 ohms of resistance and 10 volts. So the power supply or the battery is going to supply enough current to satisfy those requirements. So let's look at how we calculate how much current. Well, we know that according to Ohm's law, V equals I times R. All right, so we have our 10 volts. equals I in our 35 ohms of resistance. Now if we divide those out, we're going to get 10 divided by 35, and we're going to get 0.286. So I, for everything, is 0.286. 0.286. 0.286. 0.286. Okay. So now that we have our current, what can we do next? We can find our voltage readings everywhere. So voltage is I times R. So 0.286 times 10, 2.86. 0.286 times 5 is 1.43. And 0.286 times 20 is 5.71. Now if we add all three of those together, we should get 10. Which we in fact do. Now the next thing we can do is calculate the power at each resistor. The power is just I times V. So 0.286, enter, 2.8. That's 0.82. For 1. $1.6. And if we look at the power should all add up because the power is the rate that energy is being used. You could actually look at the power of the resistors as the energy being used, or the rate of energy being used, and that should add up to the power coming out of the battery or power supply, because that's the rate that power is being delivered to the circuit. 2.86. And these have units of watts, these have units of volts, these have units of amps, and these have units of ohms. So that's how we do a series circuit. Now, pause the video and take a look at the next circuit. When you've completed that, come back and I'll have the answer key for you. So let's look at this circuit. So what do we have? Well, coming out of the battery, we know there's 12 volts and there's 1 amp. We also know that R1 is 25, R2 is 5, R3 we don't know. However, let's look at what we can calculate. We can calculate the total resistance of the system. We know that the total resistance of the system is going to be V divided by I. If we use Ohm's law, V equals I R. So to find R, we can take V divided by I. So if we take 12 divided by 0.1, that gives us 120. The next thing in the circuit that we already know is that all of the resistances add up. So we have 25 and 5, which is 30, plus the unknown has to equal 120. So this is going to be 90. 120 minus 30. Next thing we know about the circuit is that the current is all 1 amp. So we can put 1 amp in here, 1 amp in there, and 1 amp in there. Lastly, if we look at Ohm's law again, we can calculate the voltages by multiplying each resistance by the current. So we're going to get 2.5, 0.5, and 9, and then our total equals 12. Okay, pause and do the third circuit. Pause and do the third circuit, and in a minute we'll do that together. So what do we have here? We have 1, 2 5 ohm resistors and a 2 ohm resistor. So let's put these in. So we have a 5, and a 2. So we know the total. Since we have all the resistors, we know the total is going to be 12. And we also know our current is the same everywhere. So we're going to have 0.5, 0.5, and 0.5. We're going to have a total voltage of 12 times 0.5, which is 6. A voltage for R3, which is 2 times 0.5, which is 1. R2 is going to be 2.5. R1 will also be 2.5. So there, we've completed 3 different circuit examples on how to analyze series circuits. So once you've mastered these, we'll go on to our next type of circuit, which is called a parallel circuit. And done.